Hello, we are going to start chapter 8.4, and we're going to repeat everything we did for a proportion, but we're going to do it for the mean. And so our parameter changes from the letter P to the Greek letter mu, and it's really important in the next couple of weeks that you recognize the difference between a proportion and a mean. So proportion describes a categorical variable that has two outcomes, and so we just looked at an example where we were describing whether or not an accident occurred within 5 miles. So that's yes or no, and we recorded the proportion that did occur. Mu is a measure that describes a quantitative variable, such as height, weight, age. Okay, so other than that, the steps don't change very much, though. We first want to check the assumptions for doing a hypothesis test for a mean. And the first assumption is that we have a simple random sample, which we abbreviate SRS. The second one is that the sample size is greater than 30, or the population is normally distributed. Sorry. And that's based on the center limit theorem. And then the third one is that the Greek letter sigma, which is the standard deviation, is given in the problem. Okay, so those are the three assumptions. And other than that, not much changes about hypothesis testing. Okay, again, we're going from the parameter P to the parameter mu. So that's going to go in our null and alternative. And then, of course, our formula is going to change. I'll show you how to do that on a calculator when we work through a problem. But the steps are very much the same. You check the requirements. Those are the three things we just said. You state the null and alternative. Now you're testing the parameter mu instead of the parameter p. You calculate the test statistic. So our formula is going to be different. We have x bar instead of p hat, and we have the parameter mu and sigma in there. We look up the p-value. Again, that's just the area under the curve, so that doesn't change once you get your test statistic. You can use your calculator or the table. Then we compare the p-value to the significance level. And I'm going to keep reminding you of this because it's very important, but we always reject the null if the p-value is less than the alpha level. Okay, so that part is important. I'm going to underline it. And then a conclusion and context of the problem. So you can see the steps don't really change. We're just looking at a different parameter. Alright, so let's do an example. This example is in the book. 40 people used the Atkins diet for 1 year. Their mean weight change was negative 2.1, meaning that on average those 40 people lost 2.1 pounds. Assume that sigma is 4.8 and use the significance level of 0.05. So remember, if the p-value is less than 0.05, then we reject. That's what that means. Reject H0. And so we want to test the claim that the mean weight change is less than 0. So the null hypothesis is that mu is equal to 0. That comes from the problem. I just underlined what they're wanting to test. And the alternative is that the mean weight loss is less than 0. So they lost weight and not gained weight. Okay, so important now that we are using the parameter mu instead of p. That has to go in the null and alternative. Then we want to calculate the test statistic. So we need x bar. We go back to our problem. That's the value that came from the sample data. So we have x bar is equal to negative 2.1. Sigma is given, so we have that part of it. N is equal to 40, And of course, the value for mu we get from our hypothesized value. Okay, so now I can calculate the test statistic. Eventually I'll show you how to do this on the calculator, but we'll just go ahead and use the formula. So I have z is equal to x bar, which is negative 2.1, minus 0, divided by sigma, which is 4.8. Oops. Stop that. I don't know why it's doing that. There we go. Sorry. Where was I? So 4.8 divided by the square root of 40. Okay, so that's going to be equal to negative 2.77. That's our z-score. Again, we can draw a picture if we wanted to. We have 0, negative 2.77, and then I want the area to the left because we have less than in the alternative. I always look at the alternative. Okay, so the next thing I want to do is get the p-value. I look up the area to the left of negative 2.77. Alright, so I have negative 2 right here. And then I go out to this row right here, negative 2.77. So my p-value is 0.0028. So I just want to report that here. Alright, and so because this is less than, I don't need to subtract from 1. That's called the left tail, and so that's my p-value. We want to compare that to the significance level of 0.05. The p-value is less than 0.05, so I know I'm going to reject H naught. Okay, so yes, my p-value was less than 0.05. I reject H naught. And I guess that's all that's asked for there. So p-value less than 0.05. So we reject H naught. Okay. And then we want to give a conclusion and context of the problem. I can go back up here. We're testing the claim that the mean weight change is less than 0. Did we or did we not find evidence of that? Well, since the p-value is less than 0.05, we're going to reject H naught and say, yes, we found evidence of that. So we found evidence that the mean weight loss for this diet is less than 0, mean weight change. Okay, so just type in something like we found evidence that the mean weight change for the Atkins diet is less than 0. Doesn't mean everyone necessarily lost weight, but on average there was a weight loss. And so based on these results, it does appear to be effective. So yes, since we found enough evidence to reject H naught. Okay, so the important things to get out of this exercise is that not much changed except for we're dealing with a mean because weight loss is a measurement, and so the parameter that we put into our null and alternative was the Greek letter mu instead of p. That's very important. And our formula changed as well because now we're dealing with means instead of proportions. But everything else, like the conclusion, stayed the same. Alright, and so one last thing, I'll show you how to do it on the calculator. So I'm going to open that up first. We'll just take a second. Alright, sorry about that. I forgot to open it before. Alright, so let's see. Now we're not with proportions anymore. I want to go to stat and then to test. And we're doing a hypothesis test about for the mean, and the one I want to use is the letter or the number 1, z-test. That's the one I want. Okay, and because we just have the summary statistics and not the raw data, I highlight stats. The next place is for the hypothesized value, which is 0. Then it's asking for the standard deviation, so we have 4.8. Then we have to put in the sample mean, so that was negative 2.1. Then our sample size was 40. And then the direction of the alternative was less than, so I want to click on that and then calculate. Okay, so I get the same test statistic, negative 2.77. I get the same p-value, 0.0028. This is just reporting the sample mean and the sample size.